Hey everyone, I'm really happy to be here today. So for the past 2 years, we've been all obsessed about finding the perfect brain. We treated LLM as like a single all-knowing oracle. We give it a prompt, we get an answer, and if it failed, we tried to make the model bigger. But anyone here who has tried to build a real product knows that eventually you hit the wall. You ask that single brain to plan, to reflect, to run tools, and it collapses. It forgets the instruction, it gets confused, it hallucinates. The breakthrough we are looking for is not for a better prompt, and it's not from a bigger model. The next leap happens when you shift our mind and start building a better team. So hello everyone, I'm Omri. I'm engineering manager at Monday. As you understand, I'm talking in English, but I'm living in Israel. From my color, you probably understand. And today I want to show you how to build this teams of agents. Today we're gonna cover three things. One is like the shift in our mental model and why we build multi-agents. The second, we're gonna talk about the core dimension, how to build a multi-agent when you try to. And finally, we're going to talk about Sidekick, our copilot at Monday, and what we learned from building this multi-agent system. So for those who are not familiar, at Monday, we're building a product that people really love to use globally. With over 3,000 employees across the globe, we have a massive variety of AI, internal and external AI products. We're trusted by more than 60% of Fortune 500, and we are basically building the infrastructure to run the company. And as you can imagine, one single agent could never solve all the use cases. So let's deep dive and quick recap about how we shift our mindset from a single LLM into multimodal. We started here around 2 years ago, like a single monolith, one brain, the oracle, one prompt, one answer. It's great for chatting. It's terrible for doing the work. Then we moved to something that we call chain. It's kind of a hard-coded flow. It's reliable. I wouldn't say it's the most creative system in the world, but it's work. It can't handle the unexpected. It's kind of a way to build deterministic system with AI. Then, for the first time, we saw the simplest kind of an agent, where we connected tools to an LLM. This is the dominant agent architecture up until today. Again, it worked, but it led agent to be a bit shallow. Still, you can see the most agents up until today are kind of with this architecture. And then we also added more data to the party. It was relevant for specific use cases, but again, it still lacked the depth. If you want to plan long-term strategy, this is not the right way to do it. And I'm gonna stop in here for a second and want to understand what was the problem with a single agent. I mean, it works. Why we need multiple agents? So I thought about four reasons for that. One is like the context pollution. When an agent has access to more than, for example, 20 more tools, and you put massive documentation on it, you get confused. You don't know which tool to call. The second one is the lack of reflection. As human being, if I ask you to plan and execute without stopping for a second and try to evaluate yourself, it just doesn't work. And the biggest trap, the third one is the biggest trap, as my opinion. You asking one person to be creative, to be precious, to be safe, and you get an average human being in all the fronts. And the fourth one is like the balagan, the prompt jungle, as I call it, is like code. I mean, you try to update the huge prompt that you have. You fix a bug in your instruction, and suddenly your agent starts speaking in Spanish, and you don't understand why. It's because you break something small, and you don't understand why it stopped working. So for the first time, we saw a specialist agent working together. We suddenly see paper like AutoGPT or like Camel AI or Baby AGI that start like splitting the responsibilities to different agents. And suddenly it makes a lot of sense. So fast forward for today, we see multi-agent all around the world. And to build them, we need to understand what is the core dimension. And again, I thought about 3 of them. I'm like the number 3. You're going to see it a lot today. So first is the orchestration topology. I mean, how you organize the agent, how they coordinate with each other. The second one is like the capabilities in the role, how you put specific skills and responsibility for each agent and how to do it right. And the third one is the communication. I mean, how agents exchange data with each other, how they share the context, how they use the memory. So let's drill in, start about the orchestration topology. Again, all this talk, there is like a lot of architecture and topologies. I'm just picking all the most important one and not talking about all the architecture out there. I chose to focus on 3, the single agent, the decentralized idea, and the supervisor. Single agent is pretty obvious. I'm not going to talk a lot about it. So the simplest one is single agent. As we know, it's fast, it's cheap, and probably it's the most perfect one for your use cases. It's not great for like a deep analysis or like deep agent that you want to drill in and do something super creative. The second one is like Swarm, it's done by OpenAI. In Swarm, each agent is like aware of all the other agents in the system. When one agent is active, only he is active, and he remains active until he hand off. This is like the terminology. He hand off all the like the microphone to another person. Again, I really love to use analogy in my talk, so you get used to it. You can imagine like a room of people, and only one of them has the microphone. So someone talk in the microphone, and then he hand off the microphone to someone else, and this person speak with the user. It's great for specific use cases. Again, it's really good for multi-domain, but it's not great for like if you have multi-agent system that's one of the agents is outside your organization. In such a case, you don't want to someone else from another company will talk with your users. So not perfect for like third-party agent. The second way of like decentralize the network, it's again the analogy. You can imagine like people, room full of people that everyone can talk with each other. It's like a conversation with different agents. It's a little bit different from Swarm. Every agent can talk with each other. It's not exactly the handoff. The agent can talk with the user. Even multiple agents can talk with the user. It's less common in production, but it exists. And we're moving to the supervisor topology type. Here we also have 3 ways to communicate with the users. The first one is the supervisor. You can imagine like team lead that deciding which specialized to call. I mean, the sub-agent has one role to do the work. In this architecture, the single agent get the user input and delegate to the sub-agent what to do. He pass them the parameter, and when the sub-agent responds, the control is handed back to the supervisor, and he thinks about what's doing next. Only the supervisor can take the microphone and respond to the user. The sub-agent are not doing it. A simplified way and variant of supervisor is like to wrap your agent as a tools. Here you trust your LLM to call the right tool in the right time. Sub-agent are passed to the central LLM. It's very simple design. The sub-agent receive only the tool call parameter. It's not great because they don't have all the context. We're going to talk about it in a few minutes. But it's like really common that you see, mostly if you're using Langar, for example. And the third way is like also a bit different. There is a misconception about like the supervisor and orchestrator. Orchestrator include supervisor inside of it. In orchestrator, you typically include one or more supervisor inside. Orchestrator is different because he's owned the global plan. He get the query, he decompose it to several tasks, and he build a plan. He orchestrates the whole running. It has a lot of freedom from one hand. On the another hand, it's really hard to debug and design, and it maybe has slow execution. And to be honest, most commonly, you will see a custom architecture. You need to remember organizations often build their own tailored architecture, and probably you can do it as well. So we talked about the topology. Let's drill in about the capabilities in the world. and how multi-agent system actually where they get the power. So you can imagine an infinite agent that each one of them is specialized in exactly what you need. I mean, if you want to do both planning and execution, creativity and prescience, both memory and reasoning, you can't do it on one person, and like you can't do it with an agent, and you get like inconsistency. This is where multi-agent get the power from. So the power is come from clarity of role. I choose to put like 4 of them. Those are the most common sub-agent you can help you when you build a multi-agent system. There is the planner, there is the researcher. The planner is the one who like can get a task and split it into multiple steps. The researcher is the one that's gathering the information. Most likely, the researcher is gonna have a tool for web search or like getting the data from your API in the company. You have the domain expert. It's someone that's got a really long prompt and maybe RAG to answer questions specifically for your domain. And you have the judge. We're going to talk about it later, but it's really hard for someone to evaluate his own response. So you can put another agent, maybe from a different model or maybe a different provider, to criticize and give like a feedback for the first agent that responds. So again, think really good about how to split the responsibilities of your multi-system agent. And for the last part is like the communication style. I'm not going to talk a lot about it because you can read about it in the internet, but I chose to talk about like few of them. Both Anthropic, IBM, and Google, and the open source, each one of them pushing these standards. They want to allow agents to connect with each other. It's mostly dependent on your topology, but I'm going to run really fast on it. First, we have the MCP. It's a client-server application. You're probably familiar with it. It's focused on fitting the data into your agent from external context. It's really useful when the tools are not yours. I mean, you're talking with third parties, and it's really centralized. I mean, the server manages all the tools. We have ACP by IBM. It's more centralized. It's also managed session and states, and it's something that the ecosystem will love mostly for the enterprises. We have A2A, which is really similar, and this is why, I mean, they share the same methodologies between the ACP and A2A, and this is why they decided to join forces and become only A2A. And we have the ANP and AACP. They are a bit different. They are more relevant for the network topology. If you have a room full of agents and you want each one of them to talk with each other, so probably this is the right communication protocol. We also, by the way, have ATP. It's our own protocol at Monday. It comes to solve mostly the limitation from MCP when you have a lot of tools. But as you imagine and understand, I'm talking really fast because it doesn't really matter which protocol you are going to use. It's not that critical which protocol you are choosing for your own system, because what really matters is your context. Because the context is the king, and this is what your agents stand on. Even Kropati says that managing context is the hardest engineering challenges we face right now. And we will see in a few slides how to handle it. But for now, remember that it doesn't really critical. I mean, you can jump between one to another. So we talked about the 3 dimensions that help you design your multi-agent system. And to be honest, there is another one. This is like the reality. The reality is totally different from the theoretical part. You can design for weeks your system, and one day in production, you're gonna see a totally different result that you didn't expect it. It's chaotic, it's unpredictable, there is a lot of edge cases. So again, make the short design and then put it in production to see how it works. And with that, I want to jump in and talk with you about the case study, like Monday Sidekick, and what we learn about building a multi-agent system. So a bit about Monday and Sidekick. At Monday, we are moving from managing to work to doing the work for you. We understand that we are really good at managing your work, whether it's like a sprint in your dev environment or it's like lead in your CRM system. Why not to start working and doing the job for you? And one part of it and the implementation of this vision is Sidekick. Sidekick is your digital worker. It doesn't just chat, it's doing the work. Sidekick can create workspaces, it can organize your board, it can send your emails, you can send him an instruction to find a venue in the US, and he will fill your board with multiple data from the web. Because it's embedded directly into your workspace, he understands the full context of your company. So you know exactly what you need. So a glimpse about how we used to work. This is Sidekick V1. This is really high-level architecture. Well, I'm taking you like 1 year ago. It has a supervisor. It has a few tools. Some of the tools are agent because they have too much tools, so we make it a hierarchy. Long story short, the main problem with this architecture that it was like in the product that Sidekick was too narrow. It was working mostly on general boards, but fortunately, we don't have only boards. We have multiple products and entities, and this Sidekick wasn't familiar with other entities and other products. So we need to shift it a bit. You're probably familiar with Monday that the main interface is boards, but we have multiple product division. Each one of them has different needs. It has different context. It has different terminology. So for example, we have Monday Dev, and in Monday Dev, you have something that's called sprint, and it's not like running in a sprint. It's like sprint of Kanban. You have CRM, and you have lead, and lead is a customer. So each one of the products, depending on which context you are, you need to understand what is the context that you can talk with your agent. Not only product, we have different entities. So you can imagine that you open your Sidekick on Monday on a doc entity on CRM. It has totally different context from opening it on board on Monday Dev. So it's really critical to understand that the context is really better. So today, I want to talk with you about like 8 principles that we learn building Sidekick. The first one is the context. We talked about it a bit. Context is the king. This is the first principle. This principle alone eliminates half of the chaos that team frustrating today. It's no matter which architecture you choose and what protocol you use, every handoff from one agent to another drop the nuance. Every tool you use drop the context. And if you don't pass the full context, you get amnesia in your agent architecture. So let's take a simple example. I want to ask Sidekick, hey Sidekick, design a modern landing page with a pricing page for my doc. So imagine you have a doc describing your product, and I want to build a landing page for this document. So I split it into 2 sub-agents. One is the one who built the layout of the website. The second is the one who built the pricing page. So each one of them doing great job, really, but you ended up getting 2 totally different pages. The pricing page is like, you can imagine like Apple style, really white and shiny, and the other one is like colorful SaaS style, like, you know, like the purple gradient of a startup that's raised his seed round, and it's totally different design. But again, each one of them make a great job, but it didn't have the context of the real query, the original query. They drift apart because they don't share state. So first of all, share context, share the full agent, not just the individual messages. This is one solution. You need to pass more context to the agent. But unfortunately, we are not there. I mean, sub-agent 1 and sub-agent 2 can see what each other doing. It's like telling the same instruction to 2 kids, and each one of them go and do a different, they have a different tones, a different color. And another way to do it is like, you need to sometimes considering parallelization, multi-agent system designed primarily for like reading tasks, but if you're having the writing, you need to consider running them one after each other. They tend to be more manageable in this way, and focus only on the writing and not like syncing with other agent. It's also possible to do it with orchestration or with the planner, but at the end, the context is going to be exploded. And this is lead me to the other part of your agent isn't dumb, it's distracted. And context is not only the king. I mean, sometimes there is like a misconception that bigger context window mean that you can explode it with a lot of context, and it's wrong. At this stage of your talk, you probably understand that I really love to use terminology. So you can imagine that something that I saw yesterday, I added in the evening, that you can think like AI attention like a flashlight. If you are using flashlight in a small room, it sees everything really clear. But if you put the same flashlight in the huge warehouses, the same light barely can see something. And the right amount of context is really depend of what you are trying to do. So if it the first analogy didn't convince you, maybe this research by Anthropic can help you understand that multi-agent system use 15x more token, so it's gonna cost you a lot. So multi-agent system use longer prompts, it has repeated context switching, and it's cost a lot, it's costing latency, it's costing quality, and you need to do something on it because you're gonna get context overflow. It's something that you're probably familiar with when you're using Cloud Code, and at the end, it stops and it tries to shrink in the context. So one way to do it is like same like Cloud Code. You can use context compression. You can take the whole context, summarize it, trim it, and pass only the relevant part to the next agent. Another way to do it is like using dynamic context. You can have a shared memory and pass only the relevant part to the relevant agent instead of every time passing all the data to all the agent. And the third principle is like a bit of related, that autonomy of the system is really is a dial, is not some. It's a spectrum. Giving an agent too much freedom, and you get drift and loops. And if you're not given freedom at all, you get a deterministic flow, and it has no power. So the art is choosing the right autonomy for each agent or for the whole system. It's critical for every decision that you made. What is the role of the agent? What is the protocol? What is the topology? And as we said, back to our use cases at Sidekick, at Monday, we have multiple groups and multiple teams. And each one of them has a different needs. It has a different context. Again, it has a different topology. And we want to open Sidekick for all. But unfortunately, like most of the company, we are separated team. We are separated floor in the company. And like Conway Law say, in short, company design probably want to design a system that tend to be same like the organization unit, the organizational structure. So in our case, we have like two internal debate, which one to use, what best suit for our need. We have the supervisor or the orchestrator versus Swarm. And if you think about it, it makes a lot of sense to use Swarm in our case, because if someone asks something about CRM, or if someone asks something about like Monday Dev, it makes a lot of sense to hand off the question to the right agent, and he will take it from there. But more autonomy means creativity. I want to give the autonomy to the CRM to choose what is the right way. And more control means like more predictability and safety. We chose not to go on the obvious solution. We chose to choose the orchestrator, mostly because we prefer predictability and we want safety over like creativity of each agent. We want to have like unified experience for the whole users on Monday, instead of each agent use different tones, like different, one of them gonna use emoji and the other one gonna be like really strong in his answers. So we chose to use the orchestrator, and it used to work. But still, it led me to the next point. Even if you made a decision that's limit the system in such way or another, try to build an ecosystem, not a monolith. Even if you're a small startup, if you're like starting building your multi-agent system, think about the next day. When we built Sidekick, we tried to build like a flexible platform. We split it into we building the core of the system. Like we have the guidelines, we have like the core of sharing the history, the context, the memory, and the orchestration, like the orchestrator. And we gave all the team the playground to do whatever they want. They can define the guidelines. They can set the tone, the prompt. They can even use MCP UI in order to share component. So we took the first architecture and we changed it to something like that looked like this. We decided to adopt the MCP protocol for our needs and make the system extensible for everyone. So you can see that we have the orchestrator that manage the memory and manage the database and like the history. And we created like an SDK that is really similar to MCP. We call it MCP++ because we extended a bit and we gave all the teams the way to expose tools, to expose prompts. It says a bit, the prompt said like, who am I? What is like a product is about? And share the resources like data that is not part of the board. And then again, we also used MCP UI. We allow everyone to share their own components. I really encourage you to check out the later talk about MCP UI to understand how it works. One of the coolest things that we are doing is that the orchestrator builds its own prompt dynamically. It means that we don't need all the prompts of all the agents. He first gets all the prompts from the relevant MCP, and especially the relevant MCP server, and compile it into the final one. So for example, if I open Sidekick only on CRM and specifically on entity that call automation, I want to get only this prompt and not like everyone. And if I'm adding it on a different one, I'm getting only the data from specific MCP. So it's like really cool idea. Which leads me to the next one. This is like a dominant pattern in the ecosystem right now. It's called critic or reflection. And it means like, in short, LLM are confident liars. They will tell you whatever you want to listen and to understand. And a single agent rarely catch the error of the first one. So you can imagine that you can split the responsibility to the doer one and the reviewer one. And each one of them can have a different model, so you can critique the first one, the results. It really works. It can't work with just a single agent, and it's something that I really encourage you to try. I'm moving to the next session because I don't have time. 3 more to go. Stay with me. Observability is a must. It's not an option. Don't be the person. It's working on your dev environment, I know, but you have no idea how it works in prod, and you have no idea how the user use your system, so you need something like that in production. In our case, we are using Longsmith. You need to understand observability is critical. It's not like single agent. You can like imagine how it works. You need to understand how each agent communicate with each other. And with Longsmith, we can get the full traces. We can get like a full trace. You can see how the handoff is happening from one agent to another, and you can see how much it costs. It's like also a plus. The next one is the evils. There are evils. I mean, this is the hardest problem. In our opinion, like you need to split it into kind of layers, how to test it. This is something that you're probably familiar with, the classic engineering way to test things. Like you have your unit testing, you have the integration, and you have the end-to-end. It's pretty similar if you're using multi-agent. You have the single agent eval. You want to test only your agent. You want to test the communication layer where you can mock the agent capability that only just check how each agent communicate, and there is no loops. And there is the end-to-end, like test full query to understand how the system work with each other. And it's really especially to understand that you can mock part of the system and not just always test all the architecture. Almost the last one, use human, like your user, to catch what the automation missed. You can't always test everything. In our case, we use thumb up, thumb down to understand how user like to use, like the answer or not. And it's something that help us a lot when we can catch it in the dev or in staging environment. And the last one, almost. This is the most important one. Before I leaving you here to like process all what I talked about, basically you need to stop listening to speakers at tech conferences. You know better than all what is the architecture of their system. Try not to ask LLM. You need to think like your agent. Try to be a researcher and understand what is the right architecture for your own system. You can invent the wheel. This is not specifically need to be those systems. You need to take one takeaway from my talk: single agent giving you an answer, and multi-agent give you capabilities. And remember, at the end, as Claude say, you're always absolutely right, no matter which architecture you choose. Thank you.